Hi and Assalamualaikum. My name is Amirul Mustaqim bin Azham. My matrix number is B1323103002. Today, we are going to discuss about our solid mechanics assignment, which is force and factor of safety analysis from actual structure. This is our assignment's agenda for today's presentation. The first one is the title, and then the name list, the introduction, the structure that we have chose, the structure free body diagram, the calculation, discussion, and lastly the conclusion. This is our group members list. The first one is Amirul Mustaqim, which is me, and then Ahmad Faiz Idham, Asfam bin Ahmad, and lastly Chin Kahim. For the introduction of this presentation, we are going to discuss about a bicycle frame that is used for everyday recreational use, capable of handling rider weight, road vibrations, pedaling forces, and occasional impacts. The frame that we have chose is made from aluminum alloy with precisely 6061-T6 aluminum alloy, a material that is valued for its lightweight, strength, corrosion resistance, and weldability. It adheres to safety standards, ensuring durability, fatigue resistance, and protection in crash scenarios, making it suitable for outdoor environments and rough terrain. This is our picture of our original structure that we have taken off. And then this is the label diagram for from our picture. It consists of head tube, top tube, seat stays, drop outs, chain stays, bottom bracket, seat tube, and down tube. And then we have our diagram of applied force on structure. The first one is the force on the seat, and then force on the handle, force on the pedal. For the normal force, we have normal force on the front part of the bicycle frame, and then we have the normal force on the rear part of the bicycle frame. This is our structure dimension. The first part is the head tube that consists of 70 millimeter length, and then the top tube 540 millimeter length. Down tube consists of 660 millimeter length. Seat tube consists of 470 millimeter length. The chain stays 320 millimeter length, and lastly the seat stays consists of 568.6 millimeter length. This is the literature review on similar structure. The main idea from this literature review is to evaluate how aluminium alloy, particularly 6061-T6 aluminium, contribute to the structural integrity and performance of the bicycle frame. From the literature review, main points that we have gathered is material selection and performance, fatigue behavior and structural analysis, mechanical properties of 6061-T6 aluminium. The articles or journal that is related from our literature review is Materials and Design Journal, International Journal of Fatigue, the Journal of Materials Processing and Technology. For the conclusion, aluminium 6061-T6 is widely supported for bicycle frames due to its strength, corrosion resistance, and ease of manufacturing. While not as strong as carbon fiber or titanium, it still offers a great balance of performance and cost. That's it from me. Thank you.
Assalamualaikum and good evening. My name is Asfar Ahmad, number matric B13231029, and I'm going to present on my part about the free body diagram. So from the simplified bike structure, this is the free body diagram that I come out with. There is three force acting downward on y-axis and two normal force corresponding to that force. And there's two force which is chain tension um, acting on acting on x-axis. So to find the chain tension, first we need to find the top value, which we find from force at the pedal times the pedal arm. pedal arm, which is 0.17 meter. And then after that, we get the chain tension by dividing the top value we get with the chain radius. And to find the normal force, we use equation of moment at the front, and we got the force at rear, which is 336.89 Newton. And then with that value, we use the total force in y direction and get the force at the front, which is 290 and 0.95 Newton. So that's all for me. Thank you.
Good evening, everyone. My name is Chinkayin, and my meeting number is 1323 In this assignment, what I might handle is the analysis. In this chapter, we need to analyze the loadings and mechanical response acting on the structure. But before the research, we need to assume that the rudder weight is point load as settled. Mass is equal to 60 kg, which is refined to 588.6 Newton. All member carries only axial force in trusses, which is no bending moment. And this is the free body diagram of the bicycle frame. For the external forces, our member as far as we already calculated. So what I might handle is the internal force. So to get the result of internal force, what we need to do is using the method of joint. To find the force member, we need to find two unknown curves. So we choose to start at point A. So at point A, the force member AB is showing 438.66 Newton, which is in compression. And for force member AC, we could get 13.94 Newton, which is in tension. After that, we start at point B. So for the force PD, we have found that it was 238.91 Newton, which is in compression. After that, the force member BC is equal to 45.94 Newton, which is in tension. That at point C, the force member C is equal to 370.21 Newton, which is in tension. And lastly, at point D, the force member D is 56.56 Newton, which is in compression. So after our calculation, what do we analyze? So what do we get from the calculation? So for the three-member head tube, top tube, stay was in compression, and the down tube, sit tube, chain stay was in tension. So after that was the discussion. So the first question is, how does the geometry of the frame affect its strength and performance? So geometry, such as the angles and lengths of the top tubes, sit tube, and chain stay, plays a crucial role in frame behavior. A steeper head tube angles make the bicycle more responsive, like good for road racing. Our sticker angle provide more stability. A longer wheel bars improves stability but reduces maneuverability. Discussing geometry encourages the understanding on both structural mechanics and user experience. So that the second question. Instead of aluminum alloy, what material selection could overcome disadvantage of aluminum? So basically, the aluminum having disadvantages such as lower fatigue resistance than steel or titanium. Also less comfortable ride due to stiffness because it was transmit vibration to the user. So in manufacturing bicycle frame, titanium alloy generally offers superior overall performance, especially for long-term use and ride comfort. Titanium frame also known for their exceptional fatigue resistance, meaning they can withstand years of loading cycle without failure. often lasting decades. They also provide a smooth and comfortable ride, as titanium naturally absorbs the vibration, making it ideal for long distance or endurance cycling. So for me, I do recommend the titanium as a bicycle frame besides aluminum. After that, what are the potential failure modes of a bicycle frame? Frame may fail due to buckling, fracture crack, or yoke failure. The seat tube may buckle if the top tube is too short or lack bracing. Preemptive strategies include proper design, material selection, and manufacturing technique. This introduces real risks and how engineering adjusts them. After that, the question 4. What is the allowable force for the structure of bicycle frame? And we assume that the factor of safety is equal to 2 and yield strength of the aluminum 6061 is equal to 250 megapascal. So we need to state our equation for allowable force, which is equal to yield strength multiplied by the area and divided by the factor of safety. So this is our calculation. So for the last question, the typical factor of safety range in bicycle frame is 1.5 till 2.0. So explain why. So for our answer is the typical factor of safety range in bicycle frames is between 1.5 and 2.0 is to balance the strain, weight, and performance. A lower factor of safety keeps the frame lightweight, which is important for speed and handling, especially in racing bike. Since the load on the bike are predictable, a high factor of safety isn't always necessary. But however, a moderate margin is still needed to account for fatigue, vibration, and unexpected import, which is why mountain or cargo bikes may use a higher factor of safety closer to 2.0. This range is ensure both safety and efficient in real world use. So that's all for my part. Thank you.
Assalamualaikum. My name is Ahmad Faiz Daham bin Ahmad Tarmizi. My metric number is B1323102995. Today I will explain about our conclusion. Our conclusion is the structural analysis of the aluminium bicycle frame confirms that it performs reliably under typical loading conditions, with all calculated axial stresses remain well below the yield strength of 6061 T6 aluminium, approximately 250 megapascal. This indicates a safe and efficient design capable of withstanding rider weight, pedaling forces, and road impacts. The highest force concentration occur in the seat stays and down tube, suggesting these areas are critical for structural integrity. To enhance performance, improvements such as reinforcing high-stress joints, optimizing tube geometry, and exploring advanced materials like titanium alloys could be considered. Additionally, incorporating fatigue testing and aerodynamic refinements would further ensure long-term durability and efficiency, especially for performance-oriented application. That's all from me. Thank you.